2 and 4 quadrant chopper drives. As we already seen during the power control, a chopper fit drive operates in the first quadrant where the armature voltage or armature currents are positive. In regenerative braking, the chopper drive operates in the second quadrant where the armature voltage is positive and the armature current is negative. Two quadrant operation is required to allow the power and regenerative braking control. The circuit arrangement of transistorized two quadrant drive is as shown here, in which it is possible to operate in power control mode as well as in regenerative braking. The first, power control mode. Transistor Q1 and D2 is going to operate in this mode. When Q1 is on, then the Vs supply is going to flow through the Q1 through the load back to Vs minus, where the current direction is positive, and when Q1 is turned off, the armature current which flows through the freewheeling diode. Here also armature current direction is same. In both the cases, the chopper drive operates in first quadrant. Regenerative braking. The transistor Q2 and D1 is going to operate in regenerative braking mode. When Q2 is turned on, the motor acts as a generator. Armature current is going to rise. This is the current path. When Q2 is turned off, the motor acting as a generator returns energy to the supply through D1 as shown like this. But in industrial applications, 4-quadrant operation is required. A transistorized 4-quadrant drive is shown in this figure, and 4-quadrant operation is possible. Here, the first one, forward power control, in which the Q1 and Q2 is going to operate. In forward power control, the transistor Q1, Q2 operates. The transistor Q1, Q4 are off. When Q1 and Q2 are on together, then the current flow will be through Q1, through the load, through Q2, back to Vs. And the supply appears across the motor terminals and armature current rises. When Q1 is turned off, Q2 is still in on position. The armature current decays through Q2 and D4. Here also the armature current is positive, but it is decaying, and the voltage is also positive VA as represented in the figure. This is regarding the power control mode. The second one, this is forward regenerative control. Q1, Q2, Q3 are off and Q4 can operate. The transistor Q1, Q2, Q3 are turned off. When the transistor Q4 is turned on, the armature current which rises flows through the Q4 and D2. When Q4 is turned off, the motor acts as a generator, returns the energy to the supply through D1 and D2. Is the flow of current. The third one, reverse power control, where Q3, Q4 can operate and Q1, Q2 are off. When Q1, Q3 are turned on together, the armature current rises and flows in the reverse direction. So then the current direction will be, this is the quite opposite direction of the armature current. When Q3 is turned off and Q4 still in on position, the armature current falls through Q4 and D2, where the armature current as well as the voltage both are negative. When both Q3 and Q4 are turned off, while forcing the armature current to decay through D1 and D2. The fourth quadrant, that is reverse regeneration. Q1, Q3, Q4 are off. Then Q2 is going to operate. When Q2 is turned on, the armature current rises through Q2 and D4. The IA is positive, whereas the voltage is going to be negative. When Q2 is turned off, the armature current falls and the motor returns energy to the supply through D3 and D4. This is how the 2-quadrant and 4-quadrant chopper drive is going to operate. If this video is useful, please like, share and subscribe.